All right. Phew. That was not easy at all. Yeah. Hello, everybody. I am Karan Sharma, and really thankful to everybody here for organizing the Google I/O Brisbane. And I'm excited. One of these ways. Okay. Thank you. Thanks, everybody. Hello, everyone. I'm Karan Sharma, and I'm from Sydney. And thankful to everybody here for organizing the Google I/O event. And today I'm here to present about Trail app. It's a multi-platform app that I built. Just quick questions before we start. So how many of you have been to Sydney before? Just raise your hands up. Yeah, a lot. Wow, that's awesome. And how many of you have used public transport in Sydney? All right, quite a few. Awesome. And that's good to hear. So we'll look at Trail app today, how Trail app solves public transport in Sydney. And so yeah, it works. So the goal for our presentation today is that we want to build an app that will, can I maximize? Our goal for today is to build an app where we have a shared code base and it works for both iOS and Android. And we want to be able to search for stops in Sydney and NSW. And we also want to see the real-time public transport information, how to go from stop A to stop B. And we also want the user to have the facility to save their frequent trips so that they open the app, just click on, and there it is. The timetable is there next to them. And people love colors. So we want the app to have customizable themes. And the app should also work for dark mode and light mode. So there's a lot that we want to do. So let's see how we can do that today. So we'll start with the project structure, how we'll structure our entire app code base for Android and iOS. And then we'll see how we can fetch the data from the network, how we can save the data in our database and do theming. We also want to see if the app had any crashes when the user is using the app. We want to know that as a developer and then be able to fix those crashes for both iOS and Android. And we also want to know what users are doing in the app. We're clicking what are the most popular stops so that we can make better UX decisions going further, which features are more important, and prioritize based on that. So let's keep going. So the project structure looks like this. It's basically a Gradle project, which is why we have the Gradle files here, the build.gradle. And so the iOS app folder is basically the iOS project, how an iOS engineer would set up the iOS project. It has nothing to do with Compose Multiplatform as of yet. So the Compose app is a pure Kotlin module. And let's see what's inside it. So inside the iOS app, we have a couple of Swift files. So I believe people are aware here. For iOS, we use Swift UI to build the apps. And for Android, we use Jetpack Compose. So we're looking at Compose Multiplatform technology to see how we can build an iOS app, an Android app using Compose, Jetpack Compose. So inside the iOS app is basically the main entry point of the iOS application. Inside the init block, we are setting up the dependency injection framework using the Koin library. And inside the body section, we have content view. So content view is basically a Swift UI that is going to display whatever the user will see on the screen on an iPhone. So inside the content view, if you see, we have Compose view. We are calling Compose view. So Compose view is basically a wrapper around the UI kit. So now we're going from Swift UI to UI kit. So if you focus at the line main view control kd.main view controller, so that is where a lot of magic is happening. So what JetBrains has done using Kotlin is that they have converted Compose-based code into UI kit. And now this UI kit can be called inside a Swift UI view. So that is what's happening behind. That's where all the magic is. So now if we focus ourselves to the main view controller of KT at the bottom, we see Compose UI view controller in blue color there. So that is basically something that we're using from the Kotlin APIs, and it takes in a Lambda. We provided the composable function to convert it into the UI kit, and then we can start using it. So let's keep going forward. And inside the Android application, for Android developers, it might be very familiar. We have the main application where we initialize Koin, the dependency injection framework, and it needs the Android context, which is only available on Android. So we do that. And inside the main activity, we set the content as of Krail app. So Krail app is now being used in iPhone and also being used in Android at the same time. So let's look at this shared code. What is Krail app? So it is basically a composable function. So whatever we put inside it will be visible on the app. Since we are using Compose navigation library, it's a multi-platform library, so it will work for iOS and Android both, which is why we're able to use the nav host API from there. So nav host is basically just a container or a frame where you can do any navigation or whatever screen you want to display will come up, and then you can navigate to another screen from there. We'll look at Trail theme a bit. So let's see how this basically works for Android and iOS. So we have different source sets. Inside the SRC folder, we saw Android main and Kotlin main before. So these both are source sets written in Kotlin language. So whatever we write inside it, so Android main will have specific things, and common main will have the common things can work for all the different platforms, iOS, web, JS. And both are in Kotlin, Android and common main here. So the Kotlin compiler will convert that into Java bytecode, and then we'll convert it into a DEX. So DEX format that the Android runtime understands, so it's native, and then we'll just package it into an APK file which has some resources, and then we basically execute that using the Android runtime on an Android device. So similarly for iOS, what happens is that in iOS main and common main, we'll write a Kotlin code, and the Kotlin or the native compiler will convert it into an assembly code with LLVM here. That assembly code will get converted into a native or machine code, and that is basically packaged into a framework or a static library. So that is the entire thing that is happening here. So once we have a static library, we can import that as a normal import statement inside a project, and we can use it. So that is what is happening, how Compose Multiplatform is render the UI from Jetpack Compose, because it converts it into a static library that iOS or Xcode natively understands, and then you can just execute on an iPhone. So let's look at here the common main. It is basically where we put in our platform-independent code. It will work for Android, iOS, JVM, and we can use certain libraries that work for all. And we don't choose how much we want to share between both the platforms, how much code. With Compose Multiplatform, you can also share the UI. So you have to write the UI only once. You don't have to write it again and again. But with Kotlin Multiplatform technology, you could actually have your UI being built natively using Swift UI in an Xcode project, and then using Jetpack Compose. But here with Compose Multiplatform, we can share everything, networking, database, UI. So let's see how that works. So on iPhone, again, we can write Kotlin code that has access to Kotlin specific, iOS specific APIs. All right, let's skip over that. So in networking, we'll use Ktor. So Ktor is a multi-platform library that we use to make HTTP network requests, use the HTTP client, and we can get some responses back from it. So it works for iOS and Android both, so we can use that very well. Let's see how we can use the HTTP client object here to make these API calls. So that object basically needs a platform-specific engine. So in the Android case, it needs OKHTTP engine, which is very popular library. OKHTTP we are using in a lot of places. And we can provide that to the HTTP client object and create the client object for Android. But first of all, we need to ensure how do we access the HTTP client object inside the common main code. So for that, we write the expect HTTP client. We are expecting that for each platform that we are targeting, for each source set that we have in our project, we will provide an actual. So if you don't provide an actual for us, for example, for iOS main, the project will not compile. So we have to provide the iOS for the iOS source set as well. We'll write actual client for that. And then for iOS, we use Darwin, and then we can create the HTTP client object. So after doing that, so we put it in our specific source sets. We can use it in our common main code. So now let's try to configure our HTTP client object here. So let's look at content negotiation plugin. So we have, whenever we make an HTTP request, we have to tell what kind of content type should I expect. So in the iOS example, we have a JSON. So Ktor native supports JSON, protobuf, XML. So we can provide the specific dependencies for that, and then that particular type can be used. So here is JSON for iOS, and for Android it's protobuf. So we can do both. And we're providing the right platform engine, that is Darwin and OKHTTP. And we can also install the logging plugin here. And for development purposes, we should be able to see logs whenever we make an HTTP request for debug builds. And that's how we can set up our configuration. So we look at expect success equals true later on. But we can do a whole lot of configuration here. So let's keep going. So inside the common main, now I have the HTTP client object reference. So I can call get on it, provide a URL, and then add some parameters, and then be able to get the HTTP response object out of it. So HTTP response object, and then on that object, if I call .body, it will convert automatically that particular JSON response, protobuf response into that particular data class, which is trip response in this case. And we're using Kotlin serialization library, which is why we have these annotations for serializable. And but one thing in mind, that JSON structure should exactly be same as this particular data class, which is why it will be able to convert it automatically for us. Otherwise, we'll have some issues. If we have set expect success equals to true, so whenever we make an API call, if there is a non-200 series error, then the app will basically throw an exception. So we need to catch it and then handle it separately. But if we set it to false, then we can just get the HTTP response object, and we can check the status out of it if it is successful or false, and then based on that. So it's purely up to how we want to configure it. So now that we have made an API call, got the data back for trip response object, and we can display it, do whatever we want with it. Now we want to make sure that the users are able to save the trips inside the database. So for that, we'll use SQLDelight library. It's actually very delightful to use this library. I love it. And what it does is basically that it converts the SQL queries that we have into Kotlin code. And it converts that at compile time. We don't have to wait for it during the build time. So it does it seamlessly. It has a plugin in Android Studio ID, and then it does that for us. So Room is also another multi-platform library. Room recently got the multi-platform support. That is the library from Google itself. So what they do is the opposite of this. They write, so with Room, we have to write Kotlin code first, and then it gets converted into SQL. So if you are somebody who doesn't like SQL or doesn't like to work with SQL, Room is the best choice for that. Go for it. But if you, but it comes with a caveat that it uses annotation processing. So we annotate our Kotlin classes with some annotations, and then it uses annotation processing at the build time to convert that into SQL. So for larger projects, there might be slower build times. But if you're happy to write SQL, then yeah, SQLDelight is a library for you. So let's keep going. So let's see how to add it. So we specifically need different drivers per platform for it to work. For Android and iOS, in this case, we have Android driver and native driver for iOS. So these driver dependencies can be added into the different source sets dependencies section. And then in common main, when we add runtime dependency here, now we can create our Android secret driver and iOS secret driver objects inside Android main and iOS main. And in Android, we can see it needs the context, obviously, because Android runs with context. And iOS, we don't have the concept of context, so we don't need that. So we just provide the database schema and the name of the database. So now we are able to create Android SQLite driver and the iOS specific drivers. So we can now use that. Let's see how we'll use it. But just refresher. So we write the SQL file here. So here I'm creating a table which has a saved trip that I'm going to go from this point to this point. That's the name of it. That's the ID for it. And at what point of time I created that table. So the SQLDelight plugin will create a database.kd file for me. For each .s file, it will create a .kd file, and it will also create a queries.kd file as well. So we'll understand what queries file does for us. So here on the left-hand side, with an insert or replace strip. So that is the SQL statement here. So what it does is basically inserts or replaces a trip whenever I want to do it. So I can call that SQL query, and then it will do that for me. So now inside the common main, I will create, so the database class was automatically created for us using SQLDelight. So I have that. And I have also created SQL drivers for each of the platforms. So I can use the drivers, pass it to the database object, get the database object in common main, and from the database object, I can get the queries object. So from the queries object, the beauty is that I just have to call a method. So now I'm calling a method of Kotlin from a Kotlin code, let's say view model or repository, which is directly performing an SQL query, executing an SQL query using Kotlin code. So that's just beautiful. So I can call query.insert or replace strip, and I can get data out of it. So SQLDelight also has support for flows, coroutines. So I can observe my data as it keeps changing in my database. So I can have reactive UIs built based on it. So now that we have made an API call, got the data, saved it in our database, now we want to show the UI to the user. We're going to show it to the user how it looks like and how they can use the app. So typically, a design system needs colors, typography, dimensions, shapes. And now with the recently Google I/O that happened, we also have motion scheme with the Material 3 Expressive. I'm sure you have played around with it. So it just keeps on adding. But for the design system at Trail, it's pretty basic. It needs only colors and typography for now to function. So we have design tokens for that. Let's look at that. For colors, we have a data class that has a couple of design tokens such as label, surface, on surface, alert, and a couple of others. It's not too advanced, but it works. So what we do is we provide the dark mode colors and the light mode colors separately. So we provide it using the composition local provider. And after that, we also have the typography styles defined, which is basically the text style in Jetpack Compose, how the body text would look like, how the heading or how the title would look like. It would have a different font, or it would have a different font size, font weight. All of those things are pre-configured here. So this is how my text looks like. So we provide that using composition local provider, and we provide it. And then overall, this is how the Trail theme looks like. So this is the root composable, which we saw earlier. So inside the Trail app, we are calling Trail theme that wraps everything. So this is how we provide the theming infrastructure to our UI and the app. So it takes in a content composable, which is basically the content of my app, and then it provides the theming to it in terms of colors, typography, and then we could also provide other things like dimensions and shapes, how far as we want to go. So let's keep going. So inside the components, we have the first component is a button. So we saw that we're not using material theme here. We're providing everything using a composition local provider. We're not using any material theme. So I can't access the material themes button here. So I have to build everything on my own. It's a custom theme. So a button is basically a box that has a clickable modifier applied to it. So the user can click on it, something will happen, I get a call back. And we can build it easily by creating a box that takes in a slot API for Compose content, and I can put in a button. I can put in an icon and text next to it, and then just keep on listening to the events. And then for text field, we can use the basic text field from the Compose Foundation APIs. It is a simple API, we can use it. And then transport mode icons, again, very simple. It's a box with a rounded shape, and then it has some letters written on it. I'm sure those who have been to Sydney and used the public transport, you can recognize what these all mean. And yeah, I really love it. Like they use letters instead of shapes, so that it can scale well. It is more accessible because as you increase the font size of a device, the text can scale as well. But if there's an icon, it's hard to scale it given certain parameters. So I really love what NSW is doing. No, nothing against any other transport, but yeah, I love this for this particular reason. So let's keep going. In the save trip card, it's basically a row. It's a, like we have an icon at the end, and then we have some text that says, okay, where are you going from and to? So we have the cards there. And inside the journey card, again, it's again pretty simple. It just has a border, it has some content in it. It's basically text content. And then when you click on it, it will expand into a different shape and then collapse into the collapse rate. So these are the most basic components that we have in the Trail app. So let's look at how we can add icons. So people who are familiar with Android might be familiar with this system that we have the source, the main source here inside RES, inside drawable, we put all our drawable assets. So the R file gets generated automatically using Gradle on Android, and then we can use it to get the particular icon here, which is the star icon. But in the case of Compose Multiplatform, we have the common main source set, as we saw, and inside that, instead of creating RES, we create common resources folder, and then inside drawable, we put all our resources. So it basically takes in the package name first, app.trail.ui, that's the package name of the module where this is located. And then we need to add generated resources, and then we can reference our icon that we want to use. So RES is the file name that gets created automatically. But if you want to rename it to something like my RES or Trail RES, we can do that as well. Cool. So we have got the UI working, the database, the networking, everything is done. Now, the most important part, how is the app behaving in the hands of the user? If a crash happens, how do I get to know about it? How do I fix it? That's very important. So here we can see a crash from Firebase. So what's happening here is that there's a log statement that's getting printed. And funnily enough, the log statement is log itself. So this is a method called log that is getting printed, that is getting called again and again and again. So what's happening here is that I was providing a custom logger to my HTTP client object, and my method's name was also log, and it had the same structure. So it kept on calling itself rather than calling my log method. So which is why this crash happened, and we can see it on Firebase. So Firebase is not directly supported in a Kotlin multi-platform library using from the Firebase official team, but there is another open source library that we can use for it. It's called Git Live, if anybody wants to explore that. So I'm using that for now. It's limited in the number of services it has, but it works for now. We can see that this crash happened on iOS 18.1. It happened on iOS Simulator, and that's actually me testing the app. So that's iOS. On Android, there is a crash that happened in production here. So in this one, it says index out of bounds. So it happened on Android 14 device for version 1.6.0, and it happened on a Pixel 4a device. And it happened around 6 p.m. on May 20. So interesting bit is that using Firebase Analytics or Google Analytics, I can also see the logs and breadcrumbs. I want to know what exactly the user did that led to this crash. So how do I reproduce it? Because sometimes it's very hard to just look at a pure crash log and understand what did the user do. So here I can see that the user went to a particular screen, view screen, clicked on mode. He selected the mode, or she selected the mode, whoever the user is. And then view screen, journey leg click, and then something the user did, and that's how the crash happens. So here what's happening is that the user is clicking on the back button. That is where I don't have this particular analytics added. So I don't see that the user clicked the back button, but I saw that crash myself, so I know that. But anyways, this helped a lot to debug the crash and try to actually fix it. So that's Android. Let's see some analytics. We also want to know how many users are using it per platform and how often they're using it. So right now on Android, they're a little bit less, even though the technology used behind the app is Android specific, Kotlin specific more. So the users are more towards iOS. It's around 250, 270, but I would like to say 300 because it looks cool, just to increase your numbers a bit, inflate it. So that's cool. So it's about 300, I say to myself. And then I also want to know which stops are popular. So people are going to the city, to the office. That's when people are using this app for. So they're going to Town Hall, Vineyard, Central. That's the people like go to the office. And these are all the places that people are going to the office from. So we get to know all of that information. And let's see what's new in the Compose Multiplatform technology. So for iOS specifically, there are a lot of accessibility improvements. For example, if you have some animations running in the app and the user has specified that I don't want to see animation, there's a setting called reduced motion. So now Compose Multiplatform actually respects that. So if that setting is on, you won't see any animations at all. Drag and drop is now supported. Predictive backhandler was a very, very like popular thing that people were asking for and expecting. Like iOS, I can see where I'm going, when I'm going back, when it will be supported. So it is now supported in Compose Multiplatform. Deep linking is now supported, which is very, very important. And across the platforms, we can do variable fonts, type-safe navigation. Type-safe navigation is from the Compose navigation library. So yeah, people familiar with Android might relate well to it. Shared element transitions, which is something like when you're on one screen, you click an icon or something, an image or something, and then going to the next screen kind of grows bigger and grows smaller. So that is called a shared element transition. It's now supported. We can do that. Previews to common main, that is something which is really, really what the developers wanted, because we want to see what we are building inside our IDE. So it was not supported with the latest Android Studio N, Naharwal, how do we spell it? But inside that, we can use the previews to common. So that's actually very good. We can build adaptive layouts using the Material 3 library now. So we can support a tablet or large screen size devices. So that is pretty cool that we can use that in common code. And there's a ton of things there. So yeah, here's a link. Go and check it out. So let's do the demo. That's the most interesting part here. I will try to see if I can demo and bring up the right screen. So let's try for that. I hope you can see it. Okay, you can see it. Awesome. So here's the iOS. We can start with iOS. Let me not touch this. I'll just move it around a little bit here. All right. Cool. So we have an iOS app here, iPhone here, and an Android phone here. Okay, cool. We can see it. So I'll open up the Android first. So this is what you see when you launch the app for the very first time. You can interact with it. Most people, what I've seen from my testing is that people don't really get that it's interactable. It's okay, but yeah, there's something that you can play around, like a sneak peek of the app before actually using it. So these are the ways you can say, okay, I want to go on a ferry. I don't want to go on a bus. You can do that. I want to go tomorrow. I want to reach today evening 6 p.m. sharp. How do I do it? We can do that. Yes. Let's share with friends. Yes, we can do that. Cool. Let's keep going. Let's Grail. So where do you want to go? So let's start from Central, which is one of the most popular stops in Sydney. I'll say Central Station. We can search for it. And I want to go to the city. Let's say Town Hall. It's just the next stop, but let's do it. So Town Hall supports train, light rail. Let's search. And then there's a funny thing. And we get the time. So in 3 minutes, there's a train. Hurry up. Gotta run for it on platform 17. And the line number is T8. And it's just the next stop. So you can click here, expand, collapse, and I can plan my trip. Click on this button, and then you can do that. I don't want to go on a train. I want to go on a bus or metro. Let's see if that works live. Yes, so there is a metro. So we can do a metro right now. Yeah, let's go. So yeah, in 1 minute. It's right now, and it will take you 1 minute. This is the journey, total journey time here. And this one is 8 minutes. You can also take a light rail. And there's an alert. Interesting. Let's see what the alert is. So L2 and L3 partial line close. Something is there, something important. So we can see that. And if we click here, we can see all the stops that are, inside. So let's have a look at the iOS app. So here I've changed the theme to something different. So when we started the app, it was orange color. So here in the iOS app, it's blue color because we can change the themes. Let's see how we can do it. We can go here to the settings and we can select any theme we like. Since my desktop is blue and pink, I'll go for the pink theme now. And I'll change it. So now my entire app is in pink theme. So if I kill the app, for example, let me try that. And then if I open it again, it should still support that theme. Awesome. And okay, let me try searching again from, let's try Brisbane, I don't know if this will work. I can see Brisbane Station. Okay. Should we go to Central or Town Hall? What should we do? Town Hall? All right. Can we go from Brisbane to Sydney? That's taking a bit longer. But it's trying to find a route for us, and we'll see if it works or not. It didn't work. But let's try Central maybe. So we will go from Brisbane to Central. All right. Let's see if this will work. Central is most popular stop, so maybe the lines would be there, going there. Oh, right. Okay. Yeah. Finally, we have something. So in 8 minutes, there is a coach bus at stand F. It will take us about 16 hours to go there. And we have to take this 176 number coach, and it has 4 stops. We have to get down to the casino station. Interesting. Don't wander off there. And then we change to platform 1 to a train station, 21 stops, and we reach at 6:50 a.m. tomorrow. Interesting. So there are a couple of alerts as well. So yeah, interesting things. And yes, there's a couple of ways we can go. Awesome. So yeah, the app also works on desktop. So it will, okay, just change everything, but it works on desktop. So we're going from Newtown to Bondi Junction here, and it respects my system theme. So it's in dark mode here. So it also respects dark mode. So if I click here, it will show us the dark mode. Many people say that they like light theme more, but yeah, dark mode is here if anybody is interested. Cool. All right, let's get back to the presentation. And I don't know what to do with this, but maybe it will go away. I'll stay. No, I don't want to do anything. Let's keep going. So yeah, thank you everybody for being a very patient listener. And the app is available on Apple and Android devices. You can go and download it, and please share it with your friends and family who is in Sydney. That's where we can keep connected in Brisbane and Sydney. And here's a LinkedIn page for TrailApp. If you would like to stay in touch, where we could keep posting something. And if you'd like to look at the source code, it's open source app. You can go here on the GitHub, and the entire source code is there, so you can play around with it. I'll take any questions if there are any.
Anyone have any questions? No, there's one question.
The work that I saw earlier with the locations that your users work on.
So I'm using Google Analytics or Firebase Analytics for it. So whenever a particular stop is selected, so we track that information. So without actually tracking who the user is, we only track which stop that the user is doing. So all that data goes up to the Google Analytics, and then from there we pass it down using BigQuery, and then we write some SQL statements there that are generated with ChatGPT, and then they help us to understand what the users are doing in the app. Yes, please.
Really good.
Thank you.
The opportunity to have the UI as well, that is fully composed.
Yeah, it's fully composed. So everything is happening inside the TrailApp composable. So we're using the Compose navigation library, and then it would just navigate. So we're using view models as well. View models also multi-platform now. So because of Compose multi-platform, we can have everything can be shared. So this app took about a couple of months to build, and initially it was built only for Android, but with Compose multi-platform, the code that I showed in the beginning about the iOS project, so that was just a small bit of code that I had to write for this app to work with iOS. And apart from doing some dependency injection stuff with Koin, so it was pretty easy to set up. So if you have an Android fully and native Android project, very easy to do iOS. Yeah. Yes, please. Yes, it's a transport NSW API. So you can go there, create an account. It will just give you the data. Yeah. It's NSW based, so they give me data for NSW. I would love to expand it to Brisbane sometime in future or some other cities, but it all depends on how flexible the APIs are. The rate limits on the APIs are. For NSW, it's pretty good, so which is why I was able to even do that. Yeah, thanks.
Thank you very much. Really appreciate that.
Thank you. Thank you.